does a reflection affect the properties of a two-dimensional figure? Think about this question during the lesson. The client wants the architect to flip the placement of the grill, putting it on the other side of the patio. Where does the client want the grill to be placed? Can a picture or an object be used to represent the problem situation? The architect flips the placement of the grill over the vertical line segment dividing the patio. A reflection, or flip, is a transformation that flips a figure over a line of reflection. Reflected figures are the same distance from the line of reflection, but on opposite sides. Where will the grill be placed after it is reflected?
Select your answer.
Remember where the original location of the grill is. Watch as the location of the grill is reflected. Here's the new location of the grill. A line of reflection is a line over which a figure is reflected. The original location and the new location of the grill are the same distance from the line of reflection. The reflection of the grill is the same distance from the center, but on the opposite side of the patio. The grill still has the same shape and size. However, the orientation or direction the grill faces has changed. Now you know that a reflection affects the orientation of a figure, but it doesn't affect its size or shape.
While updating the design, the architect accidentally clicked on the chair and reflected it across the center line. Draw the new location of the chair on the plan.
I'm going to assume that this is the chair. And let's put the new location. So we're reflecting it across the line. So here's our line of reflection. And so it'll be about... Can I move it after I draw it? Okay, it'll be about there. It'll be a little bit more over to the left. I thought I could draw it and then move it over, but it'll be about here-ish.
Polygon ABCDE has vertices A, -5, 2, B, -5, 4, C, -4, 5, D, -3, 5, and E, -3, 2. Graph and label the vertices of A, B, C, D, E and its image, A', B', C', D', E', after a reflection across the x-axis.
All right, so they graph that. Then you have all your vertex points shown, and then you move it 2 units below. Okay, so we're reflecting it, so it's 2 spaces from the line here. It has to also be 2 spaces from the x-axis here. And then you have it drawn, and then again it's a reflection, so it flipped right on over. And if you were to fold this, if it was a paper and you fold it, they should both be in the same space, taking up the same space and the same direction.
Quadrilateral KLMN has vertices at K, 2, 6, L, 3, 8, M, 5, 4, and N, 3, 2. It is reflected across the y-axis, resulting in quadrilateral K', L', M', N'. What are the coordinates of point N'?
Okay, so I'm going to explain, I'm going to see if I can explain this without drawing it. It's asking us the coordinates of N. if you notice all of the points in KLMN, you know what? I have to draw a picture. I can't show this without drawing a picture. So here's a quick picture of the graph. We do know that we have quadrant 1, 2, 3, and 4. We also know that in those quadrants, these are all positive, the X and the Y. Let me write it this way. So our X and Y here are positive in quadrant 1. In quadrant 2, our X is negative and our Y is positive. In quadrant 3, we have negative X and Y. And in quadrant 4, we have a positive X with a negative Y. So with that example or visual here, is asking what is the coordinates of point N after being reflected. So if all of these are positive, that means this figure or quadrilateral is drawn in quadrant 1 where both are positive. So we're reflecting it across the y-axis, and let me label the axis just to be clear. This is your x, this is the y. So if we're reflecting across the y-axis, that means we're reflecting across this line here. So we're going to, if we reflect it onto this side of the y-axis, that means that my figure or quadrilateral is now in quadrant 2, where my x is negative and my y is positive. So that means that my n should be -3, still positive 2.
What is a rule that describes the reflection that maps parallelogram ABCD onto parallelogram A prime, B prime, C prime, D prime?
All right, so a reflection maps every point of ABCD to the corresponding point. So there's a reflection across the y-axis. Okay, each point of the pre-image ABCD is the same distance from the line of reflection as the corresponding point of image ABCD. A reflection maps every point of ABCD. Okay, so parallelogram reflected across the y-axis. So as you see, it's the same. If it's a piece of paper, you fold it, it should be the same. Okay.
Polygon ABCDE is reflected across the line x equals -2. Graph and label the image A prime, B prime, C prime, D prime, E prime. Is the degree measure of angle A equal to the degree measure of angle A prime? Explain.
Okay, so it's reflected across the line. Okay, and x is -2. So this, okay, I have to see the picture of the example again. Okay, so we're gonna take this picture and reflect it. It says across the line, but it doesn't say which line. Okay, let's assume it's across the y-axis. So it says x is -2. This is my x-axis. This is -2. So I gotta also look on the reflection. It would be positive. Wait, hold on. 1, 2, 3, 4, 5. So this is actually -3. So x will be -3 here. I mean +3. 1, 2, 3. That's okay. And now let's keep drawing the rest of this polygon. and here. Okay, there we go. So there's our reflection. And yes, the angle A, it should be the same measurement of this angle A because they are congruent. It's just a reflection of what we had before.